Hi guys, Lucas here. I'll be talking to you a little bit about the map interface, which is very important for Java interviews. Most interviews for Java are asking about the internals of the map interface, like the classes that implements the map interface. For example, LinkedHashMap and HashMap. We are going to talk about the tree map in another video, okay? So let's go. The map interface, a few definitions, alright, is a data structure that stores entries where each unique key maps to a specific value. The entries will be the key value pairs, okay? Enable efficient insertion, retrieval, and deletion, commonly used for fast lookup scenarios, mapping IDs to objects, or storing configurations, okay? It's very used for cache scenarios, for example. Differently from interfaces list or set, okay, map does not extend the collection interface directly, okay. They have unique keys, okay. You can't duplicate the keys, but the values can be duplicated. Key methods include put, get, and remove, contains key and size, constant time complexity for inserting, removal, and retrieval. In the case of the put, as we're saying that it only allows unique keys. If you put a key that already exists, you try to put with another value, the the value will be set to the new value, okay, and the older value will be discarded, and of course the key won't change, okay. If you try to put an existing key with a new value, the old value will be replaced and discarded. Okay, let's go. So a little diagram showing how one depends on another. For example, the linked hash map, which inherits from the hash map, which implements the map interface, and the tree map that implements the sorted map interface, which extends from the map interface, which is the center of our video, okay. The internals of the hash map. The hash map is not thread safe. What it means, it throws the concurrent modification exception if you are iterating over a hash map and it detects that other thread tried to change the structure of the hash map. So if you are traversing a hash map and another thread tries to change, you will get the concurrent modification exception, okay. The hash map uses an array of buckets, also called table or bin array, okay, to store key value pairs, and each bucket can hold one or more nodes, okay, and the nodes will encapsulate the key, the value, the hash code, and a reference to the next node in case of collision. And so the hashing and index calculation, okay. If you are using the get or put, for example, or removal, the part of the hashing and index calculation will be calculated for those operations. All right, in this case, when we are using put, the hash code is invoked of the key that will generate an integer hash code. This hash code is then used to determine the bucket within the internal array of buckets where the key value will be stored. Okay, and the bucket is determined by calculating the scramble hash and applying a bitewise AND operation with the total capacity of the bucket array minus 1. Right? The collision handling of the HashMap until Java 1.7, okay, until Java 7. If the two different keys produces the same hash code, okay, or different hash codes map to the same bucket index, a collision will occur. Alright, and to handle these collisions, Java uses chaining, okay, using a linked list where a colliding bucket, nodes in a colliding bucket were stored in a linked list where the next pointer in each node will point to the next node in the list, and the key value pair, the nodes, of course, was inserted before Java 8 in the head of the linked list. And if many keys hash to the same bucket, searching for a value requires traversing the entire list, leading to performance degradation, okay, leading to linear time complexity. So it is very important that you create your hash code method correctly. Retrieval. When the get method is called with a key, of course, the hash code is computed and the corresponding bucket is calculated. The HashMap will navigate to that bucket, will traverse the linked list within that bucket, comparing the provided key with the keys of the nodes using equals method until a match is found. The associated value is returned, and worst case scenarios could lead to linear performance. Okay, as I said, it's always good, it's almost good, it's mandatory to create an efficient hash code method, okay, for the key. Plus Java 8, the collision handling is different, especially because the key value pairs are inserted in the tail of the linked list, because before Java 8 they were inserted in the head of the linked list. Java 8 introduced the mechanism where a linked list in a bucket can be converted into a red-black tree if the number of nodes exceeds a certain threshold. This will optimize the search time from linear to logarithm in worst case scenarios. Okay, when get is called with a key, hash code is computed and the corresponding bucket is found. It traverses the linked list or the tree within that bucket, okay, comparing the provided key with the keys of the nodes using equals. Almost the same story as the before Java 8, But of course, the difference is that they have now the red black tree after a certain threshold. Okay, a small graphic here showing that each bucket will go to a single linked list. Okay, showing the buckets and the list here, the linked list here, and each bucket handles the collision using chaining and linear search performance within the bucket in worst case scenarios. And plus Java 8, bucket with fewer elements. Here it's not saying that it is expandable, but in Java 7 the array of buckets is also expandable. Okay, and here saying that the collision handling evolves based on the count. When elements reach the threshold more than 8, it is converted to a red black tree. Improve site search performance to logarithmic, and when the list count, the tree, is lesser than 6, the tree is transformed in a linked list again. Okay, rehashing. The hash map has a load factor. Okay, that determines when the map should be resized and when the number of entries in the hash map exceeds the capacity multiplied by the load factor, the hash map will be resized. Okay, and the internal capacity is doubled. So if you have an array of size of 16, it will be multiplied by 2, and the size will be 32, and all the entries will be then rehashed and redistributed into a new larger array. Okay, and this is potentially an expensive operation. And why resizing is dangerous? Because resizing happens during a put operation, which lacks the iterator safety check. Multiple threads can enter the resize method simultaneously without being stopped by an exception. Okay, and this could lead to several critical issues. For example, infinite loops in older Java versions, because each new item in the bucket was added to the head of the linked list. The concurrent resizing could cause the internal linked list to form a cycle. Okay, a subsequent you are resizing, a subsequent get operation could then enter into an endless loop consuming 100% of the CPU. In this case, only pre-Java 8. Okay, but these two other cases are still likely to happen. For example, one thread might overwrite the changes made by another thread during the transfer of entities into a new larger array, leading to missing keys. Okay, race conditions. Without external synchronization, there is no guarantee that updates to the internal table array will be visible to the threads in the consistent way. So in a multi-thread environment, if you have multiple threads accessing a hash map, don't use HashMap. Use the concurrent HashMap, for example, okay? Because it is designed especially for thread safety. And if you need a full locking, complete locking, you use the synchronized map, because the concurrent hash map is more efficient and it locks only the bucket, okay? After Java 8 it only locks the bucket, and the other buckets are free, okay, are free from locking. It's after it works like that after Java 8, because before Java 8 it used segments, okay? I think maximum 16 segments. Alright? Why HashMap does not launch concurrent modification exception during concurrent resizing? It's simple, because that exception is specifically designed to detect modifications during iteration only, not during standard operations like put or get, for example, okay? The linked HashMap internals, okay? Remembering that the linked HashMap inherits from HashMap, the HashMap structure. It maintains the insertion order by utilizing an internal double linked list in addition to the hash table structure, also called the array of buckets, inherited from the HashMap. Here's a breakdown of how it works. The linked HashMap extends the HashMap, so it still uses a hash table to store the key value pairs and provides the constant time average time complexity for operations basically like put, get, and remove. Uses the double linked list for ordering. Each entry in the linked hash map is not just stored in the hash bucket, it also becomes a node in a separate double linked list, alright? And this list links all the entries in the order they were inserted into the map, alright? The internals, the entry structure, okay? Each entry object contains the key and the value of the mapping, the hash value for efficient lookup in the hash table, almost likely the same structure of the node in the hash map at this point, of course, and the next pointer, forming a singly linked list within each bucket, okay? And of course, after reaching a certain threshold, after Java 8, forming the red-black tree, right? And the before and after pointers, this is new, which are crucial for maintaining the insertion order in the doubly linked list, okay? The insertion process: when a new entry is inserted using put, it is added to both the hash table and the end of the doubly linked list, obeying the insertion order, alright? The before pointer of the new entry will point to the previously last entry element, okay, or entry, whatever, and the after pointer of the previously last element points to the new entry. The linked hash map, the iteration order: when you call iterate over key set, entry set, or values, okay, of a linked hash map, the iteration will follow the order defined in the double linked list, okay, preserving the original insertion order of the elements. Here we show how each node is formed. We have the key, the value, the next element in the bucket, and the after and the before using the doubling linked list. Okay. In the next video we are going to talk a little bit more about the tree map, and I'm then going to make another about the concurrent hash map. And the concurrent hash map is way different before Java 8 and after Java 8, especially when we are talking about rehashing. Okay, I'll see you in the next videos.